Hello my friends and elders, how are you all? I hope all are you doing great. And today's topic is from class 11th, Newton's law of motion. Today's topic is about Newton's law of motion. What's the Newton's law? Before studying Newton's law of motion, we will know about the forces. How the kinds of forces will be worked, so we can write as force. The force has four parts. One is the connected force. One is the contact force, connected force. Non-connected force. Weak force. Another is the nuclear force. So today we will talk about these are the four forces. One is the connected force, means where the forces will be connected. Somehow if I will take example of this is the tension force is the example of connected force. Another is non-connected force is electromagnetic force. Electromagnetic force and gravitational force. Gravitational force. Weak force. Those forces are weak. Okay, this term is known as the weak forces and nuclear force. Which forces are in the nucleus, in the atom. These forces are named as nuclear force. Now we will move on to the Newton's first law of motion. So now we will move on to the Newton's first law of motion. This chapter will be named as mechanics, and Newton mechanics will be given in the year of 1642 to the 1727, and will be read about the Newton's first law of motion. NLM's first law. NLM is the short form of Newton's laws of motion. Here we will be talk about what is the rest and what is the motion. If a body is at rest, suppose that is a body, if you will be not applied any kind of forces into the body, then the body will be not moving. If you will be applied some force into it, the body will be change its position. Okay, so what is the Newton's first law of motion? If a body is at rest, it remains at rest, and if a body will be at motion, suppose there is a car and the car will be moving. The car will be moving, okay? When the car will be moving with a constrained velocity and the straight path, if until and unless you will be not applied any kind of forces from external. So what is the Newton's first law of motion? If a object is at rest, motion, the body is at rest and motion, means the body remains at rest and motion, and this until and unless produce force from external. So that is the Newton's first law of motion. Now we'll move on to the some numericals of Newton's first law of motion, how the body will be at equilibrium. Newton's first law of motion says about the inertia. What is the inertia? Inertia is this thing. And inertia is the property of a matter that if the body as it rest, means it does not change its state, this is known as inertia. So let's do some examples and numericals of inertia about Newton's first law of motion and one experiment about the inertia. Everyone everybody can see that I will take a glass, and here I will take a piece of paper, and I will take a coin. Okay, so when I will hit the paper, the coin will be dropped down because of its inertia. Means, we will take the example another time. That you can see, that is a glass, and here I will place the paper, and that is a coin. When I will hit the paper, when I will hit the paper, the coin will be dropped in the glass. Now we will do some numericals about Newton's first law of motion. Means how we can take the body as a equilibrium. What is the equilibrium? While you will be applied a force, and the direction will be opposite, and the net force of the object is 0. Here I will take a block of mass 5 kg. Here there I have applied a force of 10 Newton in the angle of 37 degree. Here there is a force of at 53 degree angle, the force will be 50 Newton. So how we can find the body's equilibrium? So everybody can know about how we can find the component of the forces. So now we can find the component of the force, that is a 10 cos 37. So 10, what is the value of cos 37? 4 over 5. 5 into 2, 8. And this component will be 6. What is the value of sine 53? Means 3 by 5. Means 50 into 3 by 5. 30 Newton. And here there is a 40 Newton. Okay. So there is a 40 Newtons. Now we can find the direction of the force, because the force is a vector quantity. Everybody can know the force is a vector quantity because it has a magnitude and direction as well as direction also. So you can write as the F vector is equals to the FBD of the block 5 kg, 50 Newton because of its weight. We can write as mg. What is the value of m? Mass will be given 5 kg into g 10. We can write as 50 Newton. Now 5 kg. There is a 50 Newton force. There is a force of 30 Newton. 30 Newton, and there is a force of 8 Newton. So, and there is a force of 40 plus 6 Newton is 46 Newton. So in the upward direction will be applied a force of 4 Newton, and the side we will apply a force of 22 Newton, because 30 minus 8 is equals to 22. We can write as the 22 I cap plus 4 j cap. That is the direction of the equilibrium forces. Is it clear to all? Now we will move on to the double block problems. Okay, basis on Newton's first law of motion. So now we can find about the normal forces. Okay, how can we find the normal force? There is a force block of 2 kg and there is a block of 4 kg. There is a force of 6 Newton. Okay, so find the normal force. We can find it easily if you will be combine the whole system. The total mass is 4 plus 2 is 6, and this force we can know the formula that F is equals to ma. We will talk about this formula on the Newton's second law of motion, but now we can remains the formula that F is equals to ma. Then A is equals to F by m. A is equals to F. What is the F? F is the force and mass, total mass. Total mass, what is the total mass? Because I will take the combine of the two blocks. Okay, so 6. 1 meter per second square. Okay, that is the acceleration of the two blocks. Now you can find the normal force. Here, the FBD of the 2 kg block, that is a 6 Newton, and there is a N. Which one is greater than? Because the body will be moved in this direction. The body will be moved in this direction, so the 6 Newton is greater than N. So you can write as 6 minus N is equals to 2 into 1. 6 minus N is equals to 2 minus N is equals to minus 4. N is equals to 4 Newton. So that N is equals to 4 Newton. Now we move on to the Newton's second law of motion. Newton's second law of motion tells about NLM second law. Everybody can know the formula F is equals to ma. Okay, so now what is the force? The rate of change of momentum is this force. Okay, so you can write as the rate of change of momentum is the force. What is the rate of change of momentum? P final minus P initial by time. So what is the F? F is equals to, what is the P? P is equals to momentum is mass into velocity. So you can write as mv minus mu upon t. Then you can write as F is equals to m common v minus u by t. What is the v minus u by t? That is our acceleration. So we can write as F is equals to ma. There are lots of questions will be in Newton's second law of motion. We will take some examples of Newton's second law of motion. Okay. Now we will take an example.